Hey guys, welcome to my channel Data Structures Hack. In this video, we are covering a prominent data structure in computer science, software engineering, and also coding interview questions. And that is trees. So what is a tree? It is a special type of graph in which the data is stored in a hierarchical fashion. So I think we would have come across like family trees, which basically tells us about like our previous generations and how we are related to them. So over there also we see a hierarchy in the tree format, right? So let us see how it can be pictorially represented, and let us also understand the concept of trees and what are the types of trees that are available, how the complexity of the data structure works as well. Okay, so for today's video, I'm gonna be using a few pieces from the game Catan again, but I would be using only those resource number coins basically. Okay, so I would be using this part of the sheet for this. So there are two things which we need to majorly understand as soon as we hear the data structure trees, and that is trees are always consisting of a parent node, that is a root node, and a child node. There can be multiple children nodes, and let's dig into it in detail as to how that is working. But there will always be a root node, and a root node is always a single node that's going to be present in the tree. So as we see, I placed this over here, this 4 over here, and this is the root node. And following that, I'm gonna have children nodes to the root. So based on the number of children I put in, I can define the name for the tree. So if I have, for example, 2 children nodes to the tree, then this tree will be defined as a binary tree. So because we already know that 2 is binary, so we all know that. And if there is a third child which comes in, that would be called as a ternary tree. And if there are more number of children from the root node, then we would associate with a different name. So let's first dive in deep into a binary tree. What does a binary tree define as? So as we already spoke about, every root node will have 2 children, and that is called as a binary tree. And in turn, every child can have at most 2 children. So let me add in 2 more children to both 10 and 11. Okay, 6. Okay. And for 11, I can have either 1 child or 0 child. That doesn't really matter. Okay, but I'm adding 1 child to just show you that it can at most have 2 children. It doesn't really need to have any children, or it's not like a restriction that it needs to have 2 child, okay? Because the root node has it. Even the root node can have a single child, that's fine, but it can still be a binary tree if 10 in turn has 2, because for the root node at most can have 2 childs in the binary tree, okay? And this 5, 9 and 2 do not have any children, so it can be 0 children, okay? So let us now look into something like, if suppose can we be pointing 2 back into 4? Is this allowed in a tree? No, this is not allowed. This would end up being a graph, okay? And as we are seeing everything, we are pointing from the root node to the child, and the child is pointing to another 2 children, and so far it's going, right? So we can see that it is a directed graph where it is going from top to bottom, okay? There is a direction over here, like this, okay? So this is how the direction works. And now if suppose there is a third child for 4, right? Like, let me add in, ignore this other line, and for say it is 3. So this would become a ternary tree, okay? And now, so we can see that there can be a lot more children for the root, right? So that tree is going to be called as K-ary tree. So K is the number of child nodes that the root can have, and that is the utmost children that every child node can have. So we now understood that the trees can be classified based on the number of child nodes it can hold, right? So there is another way of classifying the trees as well. And what are those? They are binary search trees. So the word binary is already included in the name of the binary search tree, which means there can be only two children, but there is an other criteria called search. So based on that, there will be few more conditions as to how the tree is going to be defined as. And there can be like min heap and max heap, which also are trees, but not based on the number of children that the root node has. And also there can be trees which are spelled as TRIES, trees, which hold characters instead of the integer. So these are also used in trees, okay? So these are other types of trees which are not divided based on the number of children which the node consists of. And what is the time complexity of trees? So we can see that the space complexity is, if there are n number, then we need n space to keep the value of everything. So the space complexity ends up to be O of n, where n is the number of elements that are present in the tree, or number of nodes that are present in the tree. And also, if we want to traverse through every node in the tree, then we would have to go through everything. So this is the space complexity, and O of n time complexity as well. So this is in a binary tree, but there are other trees as mentioned, like binary search trees and others, in which the time complexity will change into a logarithmic space, logarithmic time, which we can discuss in a later video. Thank you so much for watching this particular video. I hope you have a better understanding of trees after the pictorial representation. Let's catch up in the next video. Thank you so much.